So we measure forces with Newton. 1 Newton of force is 1 kilogram meter per second squared. So Newton is this. This is the unit. Right? Newton. Same. Kilogram meter per second squared. This is like meter per second squared acceleration. Acceleration times mass. Mass is kilograms. Acceleration times mass. First law of motion. Newton's first law. Motion or at rest unless acted upon by an unbalanced outside force. In other words, if I had a ball just sitting on a table like this, it stays there. Does not move because the forces are balanced. This is what's called a free body diagram. Free body diagram. We have a force due to gravity. Force due to gravity is F sub G. We have an opposing, equal and opposite opposing normal force. So, just like the pen is pushing on the ground with gravity, if gravity is pulling it down, the ground is pushing up on the pen, equal and opposite. So it becomes zero. It's balanced. That's why it's not moving. Balanced force. There's still force acting on it. Force down from gravity, always. Force up from the ground. If there was no force up from the ground, it would be falling through the floor. But it's not. It's just standing. It's at rest. An object at rest will stay at rest unless acted upon by an unbalanced outside force. This and this balanced because pushing the ground, the floor, pushes up just as much as the gravity pulls it down. No motion. In space, you know, outer space, if you throw something, it just goes forever. No force. Motion, no force. If this floor had no friction, this just keeps going forever. Like air hockey, you know, air hockey, or ice. Ice is very slippery, so if you slide something in place, it just keep going. So, like here, I'll do this example. Ice. Can't hang ice. It's very slippery. And you have a puck that's moving. It will keep moving and slide across the ice. There's no friction. Just forever, because ice is very slippery. No friction. There's still gravity pulling it down. Pulling it down, so there's still no force pushing it up. Normal force of gravity. Balanced. No motion up or down. No motion. But because it's moving sideways, there isn't a force pointing that way. And there's no force pointing that way either. It's just moving in that direction. Force, not the same as motion. Because when I let go, no more force. It just keeps going. So that's the first law. Is an object at rest will stay at rest unless I have an unbalanced force. Unbalanced. Balanced force is no motion. Unbalanced force is motion. Balanced force is no motion. Unbalanced force is motion. That's what we can balance. So right now, I'm not moving. My forces must be balanced. If there was a strong wind pushing me this way, I'd have to push against the wind to not move. So the first is that. Second law of motion. Because there are three. Second law of motion. Second law of motion, really quick. F equals ma. Force. This thing. Newton's force is equal to a mass times acceleration. Kilograms, mass, meters per second squared, acceleration. So a Newton is equal to a kilogram times acceleration, which is meters per second squared. A mass being accelerated is a force. A force is a mass being accelerated. A mass like this, accelerated, I have to act with my arm, force, to accelerate a mass. The bigger the mass, the bigger the force. So big mass, little acceleration, big force. Little mass, little acceleration, little force. Little mass, big acceleration, big force. Force, mass, times acceleration. The third one before we go is for every action, there is an equal and opposite reaction. Meaning, if I throw this pen, I am pushing this pen with a force. The pen pushes back on me. It resists my force. So if I pull on this, me pulling on this, it pulls on me. The same amount. So this must be pulling me this way just as much as I'm pulling it the other way. Just like when I'm standing on the ground. Gravity is pushing me down. The ground is pushing me up, equal and opposite. So I'm not moving. I'm not moving. I'm being pulled down with a force due to gravity. The force due to gravity is the acceleration due to gravity times my mass. So I'm like 54 kilograms, pretty light, times 9.8 meters per second squared. That's my force due to gravity. So that's going to be like around 530 newtons, like about halfway newtons down. And the ground pushes up with 540 newtons. Same, equal and opposite. It must, or else I would be moving. I would just fly up in the air, or I would be floating to the ground. It's equal and opposite. Like if I'm in space, like a rocket ship, or if I'm an astronaut, space person. If I'm in space and I throw this object this way, I will float backwards, and this object goes that way. So, like, I'll draw a picture. I'm in space. A wrench. And I'm in space. Space. Not moving. If they throw the wrench, so not moving, if he throws the wrench, like it'll be like that goes that way and I go this way. Equal and opposite force. That's how rockets work. A rocket throws gas that way, which pushes it down. But throwing fuel, mass, like a rocket, throws it that way. It pushes equal opposite force down. That's how rockets work. So the rocket works the same way. Where I have something in the opposite. The force is going this way. The fire, the fuel goes this way. The rocket goes this way. Throws. It's like I'm here. I'll keep going more that way than what I throw down. Second, force is equal to mass times acceleration. Force